Welcome everybody, my name is Ochiniwa and I am a Twitch streamer, and from time to time I do YouTube videos. And today I would like to take the opportunity to make an introductory tutorial into the circuits network of Factorio. This is a topic that may be very complex and very difficult, but it can also be very easy. Today, I am not going into the most complex explanation about how you do certain things. Today, I'm trying to give you a very broad overview of the circuit networks in Factorio. There have been a couple of updates since the patch came for Factorio Space Ace. I'm not going into the details of these updates, so this is a fresh introduction to the circuit networks for whoever wants to get a basic information and understanding of how this works. The video will be in two parts. The first part is a general introduction about what is a circuit network, how does it function, what's the purpose of it, and how do I set it up. And the second part will give a very slight overview of the various tools that you can use, so you get a general idea about what you can do and how you can do it. I am not going into the detail of every single item. However, if the feedback on this video is positive and there is a demand, I will go into specific aspects as requested. So if you have any special comment or you have any special question, well, feel free to leave a comment below and I will certainly revert back to you. As mentioned in the beginning, I also stream on a daily basis on Twitch, so you can also join me there. If you have specific questions, don't hesitate to jump in, ask any question you want. I will always be more than glad to help you and to guide you. Okay, without further ado, let's jump into the general description of what is the circuit network in Factorio. In a nutshell, you have in every single building has a number of information which is available at that specific building, and you can basically exchange that information over a network. So you can create a specific network which will exchange information, and you can have the buildings react if certain conditions are met or if certain conditions are not met. So you can basically dictate what the building can do and what it should do if certain conditions are fulfilled. Let me give you a short overview. So you have two different networks. There's only two networks available. They are exactly the same. We call it the green and the red network. So there's no difference between these two other than the color. Why are there two? Well, in certain specific cases, you might need an information from a certain network and then another information from another network, and then compare the two so that it works. So certain items you might actually need two sources or two exits in order to be able to handle that. Once you get into the networking and once you start putting down the cables and information, you will very soon find out what's the use of the two different networks. For the basic stuff, only one is needed. So it doesn't really matter whether I'm talking here about the green network or the red network. It's exactly equivalent, one or the other. So how do I set up a network? The most easiest part is you basically pick one of these two icons. So if you don't have them on screen, you basically click on this small button here, and then you can basically here scroll and find those cables. So here, this one, that's the green one, and here is the red one. So if they don't appear here, you can basically activate them here on this small item. So let's start with the green. How do I link certain items or certain objects? If I take the cable and I basically hover over an element, you will basically see a small yellow square appearing around the object, meaning that I can basically link that. So I can try, if I, for example, try and link the wire to the railway, it says basically cannot connect. So if it cannot connect, we obviously know it can't, but you could connect here. Like if I want to connect these two items here, the inserter with the chest, I basically take the cable, so I basically click on it so I can attach it somewhere else, and then I click on the other item and these two are now linked. So you basically see it here, there's a small icon here appearing on this chest and you see the cable going onto the inserter. if you want to connect something on a long distance, so if I would want to connect, for example, this chest here to this beacon. So if I go here and I click, it says cannot connect the wire. Okay, let me try. Yeah, if I want to connect it to here, so it says cannot reach. So these cables have a distance which you can basically connect. So if you want to go over a longer distance, you actually follow the electrical posts here. So I would basically link it here to the substation, and then go to the next substation, and then go to this substation. So you see here a green wire appear, goes from here to here to here and there. So that's how I would basically connect this box to this. And if I have another chest here or any other item here, for example, if I put a chest here, I could then from this wire go onto this chest. So now this chest is actually linked to this chest. How do I unlink? You basically, when something is linked, you go back the same way. So I go from there to there. So it unlinks. I go from here to here, from here to here, from here to here. So this is now all unlinked. What happens if you basically do that? If I look on this chest now, so this chest is linked. If I open it up, I have here an additional window that appears. So if I take another chest, that window is not there. If I take this chest, I have an additional window. This window changes depending on what item is actually linked. So if I take, for example, this one looks different, and this one looks again different. So here I basically decide what happens to the network. So in this specific case, I say read the contents. So basically the network reads the contents of the box and puts it onto the network. And here I basically say enable or disable. So this is actually reacting. So if I basically enable it, I can give it a condition. Now, in order to see exactly, one of the tricks to see what is the information that is actually going in between these two, what is very easy is you basically put any electrical poles here, and then you connect the same network, so in this time a green one, to that electrical post. And if I hover on this onto this electrical post, so you will basically see it appear here, it basically says, okay, there's a green, so you see the green background of those two icons. So on that network there is the information. There are 100 belts and 250 railway signals in that chest. So if I look here, yes, there's 100 and 250. So there's 100 of these, and this one is fluctuating between 240-ish and 250. So that's the information in that network. Now, if I were to add an additional item here, and I would request, for example, some long-handed inserter, you will see once these inserter are being delivered, that signal will be added to the network. So up there they are, and you see now there is a new signal in the network. Now we also see the inserters, and obviously, as you can notice, the inserters disappear and reappear because they are basically put in the chest and then taken out again. So that value fluctuates. Now, if I put a red cable here between these two, here you basically will see, and I have it saved. Now I have on the red network and on the green network obviously the same information, but it could be different information. Here it's the same because it's linked to exactly the same items. And in this case, we have two networks, and both networks deliver me the same information. So the network basically can help you take out information of certain items or certain entities. The other part which you can do is you can decide if certain conditions are met or not. So I know, for example, on this network, there is first the railway signals, second the belts, and third the inserters, which is an information. So I can basically base the decision here and say, okay, this one is active if a certain condition is met. So here in this case, I would say if the green belts is less than 50, you will activate. Now I know here on that there are exactly 100 green belts, and basically he says here 200 because he takes both networks. So he basically looks at the green and the red network. There's two networks, so he basically doubles it. If I take away the red one, you will see that this one will fall to 0, the red one, and it will only be the green. So there is a signal, there's 100 green belts information coming in. So is that bigger than 50? Is that smaller than 50? In this case, no. So he's not enabled. If, however, I do here a higher, so in this case it is higher, and therefore it is activated. So this is the way of exchanging information between two different elements in the game, so two different units, two different buildings, chests, inserter, and whatever. So there's many different things you can actually link up and experiment around with it. So that's just a flow of information between these two. So you cannot really in this way manipulate or change that information. In order to change or to make certain decisions if certain conditions are fulfilled, so this is a very easy one, but there are different elements in the game which allow you to take that information and then to treat it and to then take decisions or within the game based on certain conditions being fulfilled or not. You will see in your building menu under logistics, you have these different elements here, which will help you to decide and make decisions based on the information that you take out of the network. You have the Arithmetic Combinator, which basically allows you to take signals and do computations with them. You can add them, multiply them, and so on and so forth. So I'll go into this a little bit further. Then you have the decider, which basically tells you to do certain decisions with the signals coming in. So we'll go through that also. And then you have the Selector Combinator, which selects specific information that comes in. The Constant Combinator is, in my opinion, the easiest one, because that one just emits a signal. Then you have the power switch, which can actually modify your electricity or cut down your electricity if certain conditions are met. You have the programmable speaker, which can emit a certain sound if certain conditions are met, and then the display panel, which can just display certain information. So I'll briefly go through for the rest of the videos through these different elements. Feel free to jump around the video to see what is what. So we'll start with the Arithmetic Combinator. As said, this one basically does calculation. Okay, I take the information from this chest and I go in. So you see there's an in and there's an out. So the information comes in here. Now, if I open this up, I will see this is the information that I get out of the box. So this box here reads the content. So it will basically read the content of the box and put that information onto the network. So here the information is, this is what is in the chest. Now I can add here certain calculations. So I can take any of this information here or any other information. I could take cliff explosive, for example, and multiply that by 200 and output that into the tick. So you will see there's nothing coming out because the cliff explosive, there are none. So multiplying this by 200, nothing goes out. So there's no output information. However, if I take, for example, the rail signal, here I take the rail signal, I multiply that by 200, and I need to take it from the red network. So here you see the different networks, green and red. So I take it from the red network. If I multiply this by 200, I get 800. So here I take a certain information, I do a certain operation, divide, plus, minus, and so on and so forth. and also there's also logical treatment, and I basically take here another information. I could, for example, take here the belts, set that. So in this case, I multiply 4 by 1000. There's a little bit more than 1000, so by 1044. So I end up with 4167 76 in this tick. So this is a calculation I do. So I take the information in and I do something with it, and then goes an information out. So I could take that information here going out, and then, for example, go onto this electrical post. If I now hover over this, I see the information down here. There's a signal coming on 4.1k clicks. So I get an information in, I do some calculations with it, and I put it out. So I could also do the following, and that is where you have this each. So I take every single information and I multiply that, for example, by 100, and then I put it out. So in this case, I end up with 248,000. So because he's basically taking the sum of this times 100. So basically that is in this case 1800, 2844, 2848. So 2848 times 100, that's 248,800. So it takes the sum of all the elements times 100 and outputs that. So that is this special character here, so which says each. So with that, so you can basically do calculations and output it. Now we will look at the decider. So again, I will take this information, I will go in here. Let me start the research here quickly. So here, I basically take the information out of this chest. Again, I have this information here. Now I can do certain conditions. So let's say I would only want to emit a certain information. So I would want to check, is there any item in there that is bigger than 1,000? So here I take this. Is anything bigger than 1,000? If yes, then you basically emit this icon with 1. So in this case, there's actually more than 1 over 1,000. So it's basically these two. So he will emit here a 1. So that is if I want to basically check in within a chest, is a certain amount available? If yes, then emit a tick, and then the tick will go to somewhere else and then activate a certain item. So for example, I could then go to here onto this inserter. Let me go back onto this inserter, and here I will basically say if tick equals 1, then he will be enabled. So close this. I will need to disconnect here because he now has two conditions, two networks. So if I hover on this one, it says target full. But if I take this away, and if I empty this a bit, you will say this one is actually working because he gets the signal out of tick 1. So if I would, for example, now put here 2000, this is no longer true. So you will see immediately this is no longer true. So he will not emit that signal. And this inserter will therefore stop working. And it says here, you will read here on the bottom, disabled by control behavior. So that's a simple way to make decisions based on information you get, again, through the network. Now I could, and that's the beauty of this, you can add here many different decisions. So you could, for example, say, if the red inserter is bigger than 1,000, and the rail signal is bigger than 0. Let me take these here away for now. And then the turbo transport belts are smaller than 2000. So bigger, that's smaller. So these three are now, the three conditions here are fulfilled. So it is, this one is bigger than 1000, this one is bigger than 0, and this one is smaller than 2000. Therefore, he basically emits a green signal and this one starts working. Now, if I would say this one needs to be bigger, you will see, okay, this one is true, this one is true, this one is not true. Since I say and, this one is not emitting anything. So if I would put here an or, so these two must be fulfilled, or this one, again, he starts. Or I could put an and here. So either this one is true or these two are true, then again, you would need to start working. And you basically see in this particular case, the inserter is starting to work. So much about the decider. Can be way more complex, but it's just to give you a general idea about what they do and how they work. The next one is a little bit more complicated, or it looks more complicated, but it's not necessarily more complicated. I will hook this one up to this electrical post. Why? In order to see the signal that is coming out. So if you want to see, because if I click on this, you do not see any signal here. You don't know what's happening inside. So that's why I basically hook it up to an electrical post. It can be any. And then if I hover over this one, I see the signal that's coming out. Currently none, because there's no information. So now I will take this chest and link it to this. Now I can decide if I hover over here. Oh, he suddenly tells me here 52. What does that mean, 52? Why 52? There is certain information here. So the select input is the first one. The select input basically tells me ascending. So he basically takes the highest item or the lowest item in the chest. So if I look at this chest, there are 52 inserters, 100 belts, and 253 rail signals. So obviously there is the least is the belt, the inserter, so that's why he basically shows me this 52. If I take descending, he will take the highest and he will give out a signal 253. So this one allows me to basically choose the highest or the lowest item in a certain signal. So if I have many different signals, he will choose the one which is the least or the highest. So that's the select input. The second information is count input. So basically the count inputs counts how many different signals are being coming into this item. And then I decide where he will put that information. I would, for example, say the check signal. And if I hover over here, he will tell me there are 3 different signals coming in. Because there's 3 different elements in this chest, so he has 3 signals coming in. So I know how many different signals come in. So that one, the count inputs allows you to basically calculate or to give you the information, how many different signals do I actually get. The next one would be the random input. The random input, if I put this a little bit, let me put this to 60, exactly 60. So that's the amount of time the information is updated. So this is ticks in the game. 60 ticks is 1 second exactly. So every second he will update and he will take a random information from here. So if I hover over here, you will see here on the right, every second he takes another element. So you don't see it change every second because the same element might be chosen twice or 3 times, but every second he decides to take an element and then randomly takes one of these elements. So that's just to randomize certain information. Can be useful, so you know it's there if you ever need it. The next one is the stack size. So if I take the stack size and I hover over here, he will tell me about all the signals that come in, what is the stack size of that element. So in this case, for example, The belts have a stack size of 100, the inserter have a stack size of 50, as the rail signals have a stack size of 50. So it just gives you the information, how big are the stacks of a certain element. This is useful information when it comes to automating trains. I'm not going into the detail of that, but know that this information is useful for that, amongst others. The next one is the rocket capacity. As the name already says, if I hover over here, he basically tells me that each rocket which is sent into space can contain maximum 50 belts, maximum 50 inserters, and maximum 50 rail signals. So this is to give you the information. If I want to basically use this to automatically fill a rocket, this can be used for that. The next one is the quality filter. So here, he will only give the information through if certain conditions are met. So if, for example, I say, tell me only the items that have a normal quality. So he tells you, okay, there is 253 normal quality, 100 of those and 52 of the inserters. So it will just filter through certain elements if the quality filter is met. So if I say, how many in there are of quality uncommon? Oh, it doesn't work. What's the use of this? I have a very short practical example for here. So I have here my whole network. I take the information from a Roboport, which basically gives me all the data that is in my network. So I take here and I say filter out everything that is legendary. Here, filter out everything that is epic. Filter out everything that is rare, and finally everything that is uncommon. And here I just, when I click on this, I take the information also. He immediately tells me these are all the legendary items I have in my network. So if I look for a certain item, I can basically say, okay, do I have that item? For example, how many legendary uranium do I have? 2.9k, and I have 145,000 legendary copper. The same for this one, so I can immediately see, oh, I have these ones epic, I have these ones rare, and I have these ones uncommon. So that's just to give an information, an overview, better overview of your network. How much items do I have in my whole network, so you can manage that. So that's a practical example for this. Can be more sophisticated, but just to give you an idea. The last information is a quality transfer. The next one is the quality transfer. So the quality transfer takes a quality, either directly the quality, and puts it onto a target signal. So in this case, we have available as target signals the rail stops, the belts, or the inserters. So I basically here say put the legendary quality onto the rail. So the output, you will see here, the input signal is these three, and the output is eventually the quality rail. So if I were to put this onto these ones, then of course I will have it. If I take any other item, there will be no output because this is 0, so he cannot input it there or output it onto this signal. So you take from, or you can say, take the quality from the rail, from these ones, and put it onto this. Now here you basically see normal inserters. Why? Because these ones are normal. If I were to request, I don't know anything. Let me see, what do I have? For example, I could request here legendary substations. So here come legendary substations, and I would here say take the quality of the substation, so whatever it is, and put it onto the target signal here. And if I look here, oh, the output now is legendary inserters. What's the use of that? That's basically if you want to program here a factory, and you would say, you would link that up. Okay. You would say this one is basically setting the recipe. So what happens here is The output is legendary long inserter. So in this case, this factory will automatically produce this and request these two in order to build it. So this is automatically now done. If I were to take and say, okay, now take the quality of this one. So now this one will actually not produce legendary ones, but normal ones. So that is in order to manage the quality of the game in terms of the production. The next one, which is, so that's the detail of these ones. The next one is the combinator, the constant combinator, which is a very straightforward item. It basically tells you to emit a certain information. So you can put in here anything you want and do this, or you can just output this one as this. So this one takes this information and puts it wherever you want into the network. So if I go from here to here, and you will see immediately now in the network I have as input all the other information. So you see it basically here on the right on the bottom. And I can also, if I want, link it from here to this one. So always the information being exchanged. So you see now there's information coming in. So the constant combinator is just telling you to take anything and put it into the network. This is useful if you want to compare something, and you would basically say, I want here a certain amount of items and I want to compare it. So you could take a green wire, go to here. So I take away the red one between these two. So here you see that's the green one and that is the red one. So I could basically take in this time, for example, the inserters, the red inserters from the red circuit and multiply that by this Z, for example, from the green, and that gives me 21. The power switch is actually very straightforward. If you link this to a power switch, you can basically tell the power switch to be enabled or disabled. So if you have an electrical network, so coming from here and then going out here, so this will allow you to switch on and off this network based on certain conditions. So if Z is bigger than 0, you see, or if Z is smaller than 0, or if Z is 1, in this case, he will actually activate it. And if I now put Z to another number, he will deactivate it. So that's just a way to activate or deactivate certain networks. So if you have an issue with power and you would like to limit the use of power in certain areas of your game, this is basically the way to go. The next one is also pretty straightforward. I can always continue here the link, so I'm going from there to there. So this one is actually an alarm. And I could, for example, say if, in this case, Z is bigger than 50, then a certain alarm goes off, or it is lower, then the alarm goes off. So you can then define here which alarm you want. So if you want something softer, here you can decide where you hear the alarm. Global means that wherever you are, you will hear the signal if the condition is fulfilled. And this is the sound node you can choose. So yeah. And you can also show the alert. So here, you see, he shows it here, custom alarm with an icon. So, and if I click on this, he will automatically go to where the alarm is. So this is to basically help you if certain conditions are met. For example, you run out of water, or you run out of oil, or a certain other condition is met, you can then switch on the alarm. Let me disable that. It's a bit annoying. Last one is the what they call display panel. So here you can just put in a signal And then if certain conditions are met, then he will basically show. So in this case, if he will show test if the amount of transport belt is positive. Now here we don't have any transport belts coming out, so I would, for example, take concrete. So if I take concrete here, you will see, oh, the item here is showing, because it always show in old mode, so you can basically switch it off and show in chart, so you can also see it here. If the condition is met, it will go on over here, and he will basically show this text. So if I, for example, make this smaller, okay, so he doesn't show and it doesn't show. So that is also to give you some warnings or some information. This is very often used for the science. So you basically would measure the amount of science you have, and if the science is missing, then you would basically show a sign here. So these are the basic elements of the circuits which you can use to manipulate them. Now, what I would recommend you to do is play around with these, look how they work, link up certain stuff. So whenever you link up something, there is a new element appearing, and then you will basically look at it and you will see, okay, this is what I actually can do, and this is actually what I want to do. So example, the train station, you can send an information to the train, you can set the limit of trains requested, you can basically read the train content, and so on and so forth. So every element here has its own information. You can link two factories together. Here I can say the factory is enabled or disabled. I want to set the recipe. I want to see the contents. I want to see the ingredients, and so on and so forth. So based on the information you get here, you can basically think of any information you would like to exchange. Okay, so that is a general introduction. Last but not least, one important information which is actually new in the space age is if you take a signal, any signal, and you put it onto the radar, and then you take any other radar, so let me put a new power pole here, and you take a radar anywhere else on the map, so you must be on the same planet or in space, and you basically link them up to another radar. So you see the information going out here, and if I look here, that's the information I get here. So anything that is put as a signal onto the radar, you can basically read it anywhere else on the map. So if I were to go anywhere else on my map here, so at the edge of the map, and I link these two, and I look here, I have, no, that was not the one I wanted. I need a radar. That was the wrong item. So I go to this element here and I'll link this radar here. Now this is the red one. It needs to be the green one. You see that I find this information again. The same information is being transmitted over the whole map. So let me unlink that because I don't need it. And there we go. So much about networks and circuits. I hope this gives you a better overview of how these things work. Feel free to just experiment around with it, click around, link the different elements, and if you have questions, feel free to drop them into the comments below, or like I said in the beginning, visit me on my Twitch stream and feel free to ask me anything. If I can help, I will be more than happy to help. If I get more feedback on specific items, I will do another video on it. Until then, well, take care and enjoy the game. Have fun. Cheers. Bye.